The formula for lithium oxide. This chemical symbol of lithium is Li. Li is in the first column of the periodic table and its oxidation state is positive 1. Oxide is derived from the oxygen whose symbol is O. Its oxidation state is negative 2. So far, we have Li positive 1, O negative 2. The total positive charge may be balanced the total negative charge. Therefore, we need 2 Li atoms to give a total positive charge of positive 2 disbalance the negative charge on the oxygen. Putting all together, we will have Li2O.
Name the compound Li2O. Li is the symbol for lithium. O is a symbol for oxygen whose root is ox, add the id ending to get oxide. When we put it all, we will get the name of the compound lithium oxide.
First, count the charge of the non-metal ion. In this example, oxygen is the non-metal ion. Oxygen has the charge of negative 2, multiplied by 2 oxygens because we have 2 oxygens in the given example. That means we have a negative 4 charge. Therefore, each titanium must contain a positive 4 charge. So, the answer is titanium Roman numeral 4 oxide. Writing chemical formula. Titanium has the charge of negative 4, so we must have 2 oxygens to balance the number of the charges, since oxygen has the charge of negative 2. Therefore, the answer is TiO2.
Binary compounds. Dinitrogen triselenide or N2Se3 for naming type 3 binary compounds. The first element's name is written first and its full name is included. So in our given, we have nitrogen. So for the second element, if it is an ion, it should have a suffix IDE in the end. So selenium will become selenide. And now we have nitrogen selenide. We need to add prefixes to the element's name based on the number of atoms present. So nitrogen has 2 atoms and selenide has 3 atoms. We are going to use a table to know which prefix to use. So nitrogen has 2 atoms, so that's why it will become dinitrogen. And selenide has 3 atoms, that's why it will become dinitrogen triselenide. Now we are going to find the formula for dinitrogen triselenide. Nitrogen has a prefix di, which means it has 2 atoms. So we are going to write N for the symbol and 2 for the number of atoms present. Next, selenide has a prefix tri.
Polyatomic ion. Polyatomic ion is a group of atoms that act as a unit and carry a charge. For example, SO4 negative 2. We can see here that it has 1 sulfur and 4 oxygen, and the entire atom has a charge of negative 2. Now for ternary ionic compound. A ternary ionic compound is composed of 2 ions in which at least one is a polyatomic ion. For example, Na2CO3. We can see here that sodium is one of the ion and the polyatomic ion is carbonate. Now for naming ternary ionic compounds. So we have here AlOH3 and we will discuss how it will be named as aluminum hydroxide. So in order to make it easier, I've listed here steps which you can follow. For step 1, you have to identify the two ions present. For step 2, identify if one of the ions is found in group 1 or 2 or if it is a transition metal. If it is found in group 1 or 2, you just have to write its name. But if it is a transition metal, you have to include a Roman numeral after it to indicate its oxidation state. Then last, for step 3, you have to name the first ion or the metal followed by the Roman numeral if it is necessary, and then write the name of the polyatomic ion without adding any other suffixes. Now let's do it with the example. For step 1, identify the two ions present. So we have here Al, which has a charge of positive 3, and OH, which has a negative charge. For step 2, you have to identify one of the ions. So aluminum is a transition metal, but though aluminum is a transition metal, it doesn't require a Roman numeral on it because it only exists in one ion. Then last, for step 3, you just have to write the aluminum and don't include a Roman numeral because as I explained earlier, it only exists in one ion. Then write the polyatomic ion, which is hydroxide. Now let's proceed to writing formula of ternary ionic compound. With the same example, aluminum hydroxide, but we'll reverse it because we'll use the name and then turn it into a chemical formula. We also have here the steps. For step 1, you have to identify the symbol and the charge of the two ions. Step 2, balance the charges. Then step 3, if there is a subscript, you have to put the symbol of the polyatomic ion inside the parentheses and then the subscript outside. Now for step 1, the symbol for aluminum is Al and the charge is positive 3. Then for hydroxide, it is OH and it has a negative charge. For step 2, balance the charges. The charge of aluminum is positive 3, therefore, you'll need 3 of hydroxide in order to balance 1 aluminum. Now for step 3, write the symbol of aluminum, which is Al, and we have a subscript of 3, so we have to put the symbol of the polyatomic ion in the parentheses and then the subscript outside. So it will be Al, then OH will be inside the parentheses, and then the subscript of 3 is outside the parentheses. Acids. Acids have covalently bonded molecules. To have a simple definition, an acid is a compound in which one or more H plus ions are bonded to a negative ion. Naming common acids. Now for naming common acids, we have to make use of this guide. We'll look for the anion ending. If it ends with IDE, we have to put hydro, then the stem, and then IC or ic, and then acid. But if ends with ITE or ATE, we just have to put the stem first and do not include a hydro anymore. The steps. Step 1, break apart the ions in the chemical formula. And also take note that the name of the acid is after the ion with a negative charge. For step 2, identify the anion ending and then use the appropriate suffix and prefix based in the guide, which I presented earlier. Now for the example, we have here HC2H3O2. For step 1, we have to break apart the ions. So the first ion is H+, and then C2H3O2, which has a negative charge. I've mentioned earlier that the name of the acid is after the ion with a negative charge. So, in this example, it is the C2H3O2 and the negative charge. So, the name of it is acetate. Then for step 2, we have to make use of the guide. Identify the anion ending and then use the appropriate suffix and prefix. So the ion with the negative charge is acetate and it ends with ATE. So we have to get the stem of acetate, which is ACET, and then add IIC or IC and then acid. So the answer will be acetic acid.